Thanks to a beautiful explanation by Chin, we now know how to find the volume of a regular object using the disk or washer method. Now we're going to learn another method called the shell method or the cylindrical method, which also does the same thing, finding the volume of a regular object. Alright, so let's get right into it. So these are the 7 steps to find the volume of an object using the shell method. So first you would take the segment that's parallel to the axis of rotation. Now in a washer or disk method, usually you do it perpendicular to axis of rotation, but it is very important that when performing the shell method that you find the segment that's parallel to axis of rotation. Second, you would rotate it around the axis of rotation. Third, you would find the endpoints. Fourth, you would find the radius, and usually it's from the point of rotation to the segment itself. And then you would use dv equals 2 pi r, and r is the radius, h is the height, dx is the width of the segment. And then next, you would find the volume by taking the integral of both sides. Then you would evaluate for the limit of integration. Okay, so now let's do some examples. Alright, let's get started with this function. It reads y is equal to x minus 1 times x minus 3 squared. Alright, and then this is what the graph is going to look like. It's going to go like this, like that, like this, and we're only finding the area between 1 to 3. So the first step that we have to do is take a segment, a little tiny segment, and we call that dx. Well, the width is dx. Then after that, we rotate it around the axis of rotation, and the axis of rotation for this problem is going to be along the y-axis. So we rotate it along the y-axis, and then we're going to be next, we're going to find the endpoints. Now the endpoints for this segment is x comma 0 and x comma x minus 1 times x minus 3 squared, so basically the function. And then after finding the endpoints, we find the radius. And the radius is usually going to be from the point of rotation to the segment itself, so it's just going to be x. Alright, now we have all the information that we need. We're going to go straight into the equation. So it's going to be dv is equal to 2 pi x, which is the radius, x minus 1 times x minus 3 squared, which is the height, because we're going to be, in order to find this height right here, you have to subtract this from this, and that's going to give you the height, and that leaves you with x minus 1 times x minus 3 squared. And then, of course, we can't forget about the dx, which is the width of that segment. And then, in order to find the volume, we have to take the integration on both sides. So when we take the integration on both sides, we're going to get, so volume is equal to 2 pi, the integration from 1 to 3 of x times x minus 1 times x minus 3 squared dx. Alright, we're just going to simplify that a little bit further. Just multiply everything in. You get 2 pi, the integration from 1 to 3, x fourth minus x 7 to the third. 7x to the third plus 15x squared minus 9x times dx. And then you just take the integral of that, and you're going to get the volume. It's going to be equal to 2 pi 1/5 x to the fifth minus 7 over 4 x to the 4 plus 5x to the third minus 9 over 2 x squared, and you plug in 3 minus, then you plug in 1 to the where the x's are, and you would eventually reach that volume is 24 pi over 5. Alright, so this next example is a little bit different, but has the same kind of steps to it. Alright, so it reads, find the volume of a solid when rotating the region bounded by x is equal to y minus 2 squared and y is equal to 1 around the x-axis. Alright, so let's look at this beautiful graph. It's going to look something like this. Alright, so this is going to be the x is equal to y minus 2 squared, and this is going to be the y is equal to x. So first we're going to have to take a segment, and when we take a segment, it's going to be right over here. You could really take it from anywhere, but I decided to take it from here. Then I rotated along the x-axis and got this segment right here. Next, I found the endpoints, and the coordinates for this one is y minus 2 squared y. This one is y. Next, I decided to find the radius. So the radius is going to be from here to here, and that's just y. Next, let's move on to the formula. Alright, so 2 pi, the radius y is right here. Then we're going to have to find the length of the height or the width, and that's going to be this minus this times dy, right here, the width of the segment that we're taking. Alright, and then in order to find the volume, we're going to have to take the integral on both sides. So we're going to get that volume is going to be equal to 2 pi, the integral from 1 to 4, and then I just simplified this a little bit more, so it's going to be negative y to the third plus 5y squared minus 4y dy. Then you take the integral of that function right there, and you would get v is equal to 2 pi, negative 1/4, y to the fourth plus 5/3, y to the third minus 2y squared. Then I get 4, I plug it into y, minus, you get 1, you plug it into y, and then this is what you would get when you plug in 4, this is what you would get when you plug in 1, and the volume ends up equaling 135 pi over 6.